Hello everyone, and we are now in Module 8, the domain and range of rational functions. So our competency is to be able to understand the domain and range of rational function. Let us see the real application of a rational function in this situation. In our study of rational function, these x values represent the domain and y values represent the range of a rational function. In definition, the domain of a function is the set of all values that the variable x can take, while the range of a function is a set of all values that y or f of x can take. But how do we determine and write the domain and range of a rational function? If you can recall, we can write the domain and range using different forms. And number one, we call this one as roster format, or we call this one as listing method. This method enumerates the list of all values in the set. Example, the domain of R of t are 1, 1.25, 1.5, 1.75, and 2. Number two, we call this one as set builder form or notation. For example, in numbers 10 to 20, you can say x and with the symbol x are even numbers from 10 to 20. This symbol is read as such that, assuming that you also include odd numbers in the domain from 10 to 20, then you can write the domain of the function d of x as x such that x is an element of a real number wherein x is greater than or equal to 10 but less than or equal to 20. So when we read this algebraic expression, we read we read starting from the middle. So we are comparing x to 10 and x to 20. So x is greater than or equal to 10 but is less than or equal to 20. And number three, we call this one as interval notation. So we are using here the union of two sets, and we are using parentheses or bracket. For example, in a function f of x equals 5 over x minus 3, the domain of this function can be written in the form of the union of negative infinity to 3 and from 3 to positive infinity. This means that the values of the domain can take all real values of x except 3. Otherwise, the function is undefined. And for our example number 1, find the domain and the range of the rational function f of x equals 2x minus 3 over x squared. So we are going to solve first for the domain. So let t is the domain. So all you have to do is to get the denominator and equate it to 0. So our denominator is x squared equals 0. Then solve for x, we have x equals 0. Therefore, our domain is equal to x such that x is an element of real numbers where x is not equal to 0. That means we can have any real numbers for x except 0 because it will make undefined the function. Next, for our range. So we will be using R for our range. To solve for range, we have to change f of x into y. So we have y is equal to 2x minus 3 over x squared. All you have to do is to cross multiply x squared to y. So we have x squared y equals 2x minus 3. Since this is a quadratic equation, we are going to transfer all the terms to the left side. So that means we are going to arrange this. We are going to write first y instead of x squared. We have y x squared minus 2x plus 3 equals 0. And this equation represent quadratic equation in the form of a x squared plus bx plus c equals 0, wherein our a here is y, our b is negative 2, and our c is 3. And we are going to use the radicand in our quadratic formula, which is equal to b squared minus 4ac. Since it is radicand, it should be greater than or equal to 0. So we are going to substitute now negative 2 squared minus 4. Our a is y, so we have times y times c, which is 3, is less than or equal to 0. Negative 2 squared is 4 minus 4 times 3 is 12. Y is greater than or equal to 0. Then transpose 4 to the right side. We have negative 12y is greater than or equal to negative 4. Now divide this by negative 12, both sides, and we have now y. Take note, when we are dividing a negative in inequality, the inequality symbol reverse. So instead of greater than, we are now using less than or equal to. Then we have negative 4 over negative 12. Simplify this, we can have positive 1/3 or 1/3. Therefore, we can have our range as so we have y such that y is an element of real numbers wherein y is less than or equal to one third. So that is our, so this is our domain and this is our range. And for our example number 2, find the domain and range of the rational function f of x equals x minus 2 over x plus 2. So let the our domain, so our denominator is x plus 2, equate that to 0. Then solve for x. We have x is equal to negative 2. Then we will express our domain as set builder notation. So we have x such that x is an element of real numbers wherein x is not equal to negative 2. At the same time, we can express our domain as interval notation. So to do this, we have to write open parentheses. Then we have here a negative infinity to negative 2. And we have the union from negative 2 to positive infinity. So any of these answer will be correct. So this is a set builder notation, and this one is the interval notation. Okay, so this time we are going to determine the range of the function. So to do this, we have to change f of x into y because we are going to solve y in terms, we are going to solve x in terms of y. So we have x minus 2 over x plus 2. So we will cross multiply. We have xy. Y times 2 is 2y equals, we have here x minus 2. In this situation, we are going to transfer to the left the terms that contains a variable x. So we have xy, we have minus x, so we transferred x here to the left. At the same time, 2y will be transferred out to the right. So we have negative 2y minus 2. Okay, so we will continue in this place. So we are going to factor out the common factor, so which is x. So we have xy divided by x, we have y. X divided by x is 1 equals negative 2y minus 2. You may factor this out or not, it's just the same. So we are going to solve for x in terms of y. Therefore, we are going to divide both sides by y minus 1. Then we have here y minus 1. So we base our divisor in this term. So we have y minus 1. So divide both sides so we can eliminate y minus 1. So we only have now x equals negative 2y minus 2 over y minus 1. So in this case, we are going to equate the denominator, which is y minus 1. Then equate this to 0. So we have now y is equal to 1. Then we can express now our range using the set builder notation. We have y such that y is an element of real numbers wherein y is not equal to 1. So this is our range and this is our domain. And for example number 3, we are going to find only the domain of the rational function f of x equals 3x squared minus 8x minus 3 over 2x squared plus 7x minus 4. So let D be our domain. Then we will take away our denominator. We have 2x squared plus 7x minus 4 equal to 0. Since this is a quadratic equation, we are going to use factoring. So we have to write 2 parentheses, then equals 0. We have to factor this first, the first term, which is 2x squared. So we have 2x and x. And then we will determine the factor of negative 4 with multiplied by 2. So, and then add or combine like terms. We, the answer should be in the middle term. So since the middle term is positive, therefore we can have here a positive 4 and a negative 1 here. So to check, just multiply negative 1 times 4 is negative 4. So 4 times 2 is 8. Negative 1 times x is negative 1. So 8x minus x is 7x. Then solve for x. Since we have two factors, therefore we have two values for x. So we are going to equate each factor to 0. So we have 2x minus 1 equals 0. And the other one is x plus 4 equals 0. Then solve for x. We have 2x equals 1. Divide by 2. Divide by 2. We have x equals 1 half. On the other hand, we have x plus 4. Therefore, we have to transpose 4 to the right side becomes negative 4. So we have two values for x, 1 half and negative 4. Then we're going to determine now our domain. So x such that x is an element of real numbers wherein x is not equal to, we have negative 4 and 1 half. So this is the answer to the question example 3. Find the domain of the rational function. And we are now in example number 4. Find the domain and range of the rational function f of x equals x squared minus 3x minus 4 all over x plus 2. So let D be our domain. So our denominator is x plus 1. Equate that to 0. Then solve for x. We have negative 1. Therefore, our domain in set builder notation is equal to x such that x is an element of real numbers wherein x is not equal to negative 1. And for our range, we will change f of x into y and we will just copy the function over x plus 1. Okay, if you notice that our numerator here is factorable. So we have x and x here. Then what is the factor of negative 4 so that the sum of which is negative 3. So we have a negative 4 and a positive 1. Then we have x plus 1. You have noticed that we have the same factor. So we can eliminate x plus 1 and x plus 1. Therefore, we have y is equal to x minus 4. So we will continue in this space. This time we are going to substitute x equals negative 1. So we will use in this equation to determine the value of y. So we have negative 1 minus 4. So y equals negative 1 minus 4 is negative 5. Therefore, our range is y such that y is an element of real numbers wherein y is not equal to negative 5.